All right, so we are live now. I hope you have seen the YouTube link that is shared in the chat, as well as I have pasted it in the calendar. Am I audible?
Yes, sir.
Yes,
Okay.
sir.
So let me share my screen and we'll start our discussion on Taylor's theorem. Okay, so we'll spend some time on Taylor's theorem and then we'll solve problems. Okay, so before that, let me share my screen. All right, so I hope my screen is visible.
Yes, sir.
Right, okay, great. And today is the deadline for week 6. Okay, so I hope most of you have gone through the lectures. And today we are going to have a kind of discussion, not like I'm going to summarize or something. What I expect is you would have all watched the lectures and you know what Taylor's theorem is, right? So we'll just revise what Taylor's theorem exactly is, and then we'll solve more problems so that we'll get more understanding on Taylor's theorem. Okay, so Taylor's theorem or Taylor's series or Taylor's expansion is basically used for approximations, right? So sometimes we know about a function in particular interval, and after that we may not have the data of the function, or we may not know how exactly function behaves. So because we don't know how the function behaves, we kind of approximate it, right? So based on the data that is available to us. So once we know the function till some point a, and if I know the behavior at point a, behavior I mean if I know the derivative at point a and double derivative and all the derivatives at that particular point a, and I want to approximate my function after a, right, in some interval, then I use the ideas. Yes, any doubt? Sorry. Okay. All right. So where are we? Yeah, so approximations, right? So this Taylor's expansion is basically used for approximations. And depending upon the degree of approximation, the better it would be. Like if you are doing a constant approximation, you may not get the exact function, like you'll have more error. As the approximations degree increase, like as you progress to linear, quadratic, and then cubic, quadruple, and so on, then your approximations will get better and better. So this degree will increase when you use more information about the point A. So if you have only the function value at point A, you can only do constant approximation, right? So before we come back to this, so what am I saying is,
Sir,
yeah,
sir, actually, I'm Chandrasekharan. I now only joined the meeting due to some network problems, sir. Sir,
okay.
actually, I want to pay my fees for this course registration. I have cleared the qualifier exam. Where should I do this payment, sir? There is no portal regarding it, sir.
Okay, so I think you are asking the wrong person. So did you ask support somewhere?
Ah, yes, sir. I mailed, but there was no reply from them.
There was no
Actually,
reply.
today after 5 p.m. the portal gets closed. After which we can't pay our fees. So actually they told it will be released by yesterday morning 11 a.m. But the result was released at yesterday 6 p.m. in the evening. So today around 5 p.m. the portal gets closed. So where should I pay itself? I don't know. So today I asked.
Okay, okay, I understand your concern, but even I'm not sure. Okay, so you do you have any support numbers you have
Sir, I
from?
tried that those numbers also, but it is not. It is just ringing, but no one is taking in the call and talking.
Is that so? No, no. Ring couple of times. They will pick. So they will be getting multiple calls, and there are many people who handles this. Okay, so
Okay, sir.
call to them, and I think they are the right person.
So,
They
okay,
will
sir.
be.
Sir, in this meeting, if anyone knows, can they tell me?
Yeah, I think Shashant and Priyanshu has replied in the chat actually. So they
Okay.
said call the support number,
Okay, sir.
and
I will try and I will.
yeah, yeah. So you should call between 9 to 6 p.m.
Okay, sir. Okay.
See, many people are replying in the chat. Okay.
Okay, sir. Okay. Thank you, sir.
Okay. All right. Okay. So what am I saying is we know the function behavior till let's say some point A. Okay. And I want to approximate or I want to see how my function behaves at some point x naught or x. Okay, where x is very close to A. And I am going to use the information that I know at point A. So that is what I need. Right. So if I know only f of A, right, nothing else. I know only the function value at A, then I can do constant approximation. What does it mean? So if I know the function, only the function value at x is equals to A, what I will say is after that also as x is very close to A, f of x will also be equals to f of A. So that is what I will say, and I'll conclude that f of x will also be equals to f of A, approximately equals to f of A. So this is f of x and this is f of A. Right? If I have only f of A, if I have along with f of A, if I know how the derivative behaves, like how the slope is changing, how the rate of change is there at x is equals to A. So that means if I have f of A along with f prime of A, then I can do a better approximation. I can do a linear approximation. Right? So what does slope do? Slope actually says how the function is moving at that particular point. Right? So if I know f prime of A also, I will move in that direction. Right? Instead of going like this, if I know that my slope is moving in this direction along with f of A, I will move in that direction and I will be much more closer to f of x than the previous constant function. Right? If I know more information, like if I know f double prime of A along with f prime of A and f of A, I can do much more better approximation, which is quadratic. Right? And like this, if I know the complete details of the point x is equals to A, like all the derivatives, right? Then I can completely characterize or completely find the value or the function, right, f of x at any point x, which is called Taylor's Taylor series. Okay. So roughly this is what it is. And we primarily, in this particular course, we will mostly focus on Taylor's theorem for linear approximation and Taylor's theorem for quadratic approximation. So we'll not go beyond quadratic, but in activities or practice assignment, you would be seeing some cubic or quadruple. But for in the exams, you might expect problems below quadratic approximation, something like linear approximation or quadratic approximations, where calculations are bit easier. Okay. So again, all these approximation, Taylor's theorem works on the idea of mean value theorem, right? For linear approximation, at least this is the statements and this is the theorem actually, right? So if f and f prime are continuous in some interval ax, and if you know that f double prime exists in the same interval, then there is a point x2, right? Some other point x2, such that my f of x is exactly equals to f of a plus f prime of a into x minus a. This is the linear approximation. This we have seen in week 5, right? So week 5 we have seen linear approximations and quadratic approximations, right? So this is exactly the linear approximation, right? And this term is called the error term. This is the error. Once you do approximation, there will always be an error. This is the exact value. This is the actual value, actual function. This is the linear approximation. And the difference between these two will be the error, right? So that is why this is called the error term. And you should observe one thing here. So I'm writing this as equals to, not it is approximately. Right? So we are not writing approximately because there exists an x2 such that you can characterize your function f of x just with f of a, f prime of a, and some x2. There will always exist such x2 such that I can write f of x in some of these three terms. Okay. So that is one thing. And what else? The proofs and all involves mean value theorem, right? So it is given in the lectures also. So you can go back, watch, see the proofs. But the thing is, at least in Math 1 course, I think professor also mentioned this. So the results are more important than the proof. Okay, if you are into math and if you want to do some majors in math, then proofs and all is very, very important. But for now, at least for Math 1, and we expect that you are going to be an electrical or electronics engineer rather than a mathematician, right? So the results are more important, and that is we work on the results. Okay. So I hope
Excuse me,
we
sir.
are at. Yes.
Uh, I just wanted to ask one thing. Like,
Hmm.
sir, in the lectures, as
Hmm.
professor told, like all the Taylor's theorem is getting derived from the Rolle's theorem,
Hmm.
and the Rolle's theorem is getting derived from the mean value theorem. So, sir, like all the three theorems are interrelated from each other.
Right. So the base is Rolle's theorem, the basic thing. From there, we generalize it and move to mean value theorem. And we'll use mean value theorem to prove this Taylor's approximation, Taylor's theorem.
And
Okay,
like
it's kind. Yeah.
for like for each time, like when we are finding uh, like the first differentiation of f, and then the second differentiation of x, and then the third until the nth power.
Hmm.
Every time the formula or the actual like the function which we are getting is changing according to that. So
Hmm.
that will happen for each theorem, like because they are derived from each other.
Uh, can you rephrase your question?
So I'm asking like in the lectures, like this is for the linear approximation with the formula we have found it out, and
Yes.
like there is a formula also for the quadratic approximation, and then
Hmm.
there's a formula for the f to the power of n.
Hmm.
So sir, like how to like apply the different types of formula. So like it depends upon the number of times in that question we are differentiating that question, or it depends upon something else.
So majorly it depends on the information that you have about point A.
About the point a and x.
A basically. A is sufficient. So that is what I said, right? So if you have only f of A, nothing else, all you can do is the constant approximation, nothing more. Okay, because you don't know f prime of A, f double prime of A, you know only f of A, then you can only do constant approximation. But if you know f of A and f prime of A, then you can do linear approximation. So like this. It depends on the information that you know about point A.
Okay.
Okay.
Okay, sir.
Yeah. So that is what. So here for linear approximation, you need these conditions to be hold true. Like you need your f and f prime should be continuous in this AX, and you should know that f double prime should exist in this interval AX. Then comes the Taylor's theorem. What Taylor's theorem says is there exists some point x2 such that your function f of x will exactly be equals to the sum of these three terms. All right. But if you know that your f prime, and f double prime are continuous, and you know that f triple prime exists, then there will exist some x3 point such that you will have more terms. You can write it as sum of 4, which is what the quadratic approximation will. So I will write it for you. So the only difference comes is this. Okay, so which formula, in your words, which formula to use is will depend on the information that you have about the function.
The information about the f of a and f prime,
Yes,
f prime or f double prime or
correct,
any place to power of that.
correct. So Taylor's theorem for quadratic will be, we need the addition would be here f, f prime and f double prime are continuous in this interval AX, and you know that f triple prime exists in this interval, then there exists some point x3 such that you will have one more term coming into the picture. Right, so I think that was okay. What we'll have is we'll have f double prime of a divided by 2 factorial into x minus a whole square, right? Because I know f double prime of a now, in addition to f prime and f. So once I know, I will add that also for better approximation. And then comes the error term f triple prime of x3 divided by 3 factorial x minus a whole cube. Okay. So here we have used the information f of a and f prime of a. But here if you see, we have used f of a, f prime of a, and f double prime of a. right? Because we know these three information to us. Okay, but the cost will increase, right? So the time you spend or energy, everything accounts to your cost. If you want a better approximation, then equivalently you should pay the cost. Okay, I hope this is clear. Again, here also you can
Sir,
see, yeah.
sir, I have a doubt. The last term gives the error of the quadratic approximation. Am I right?
This is error because this is the quadratic approximation, right? So this is q of x. The first three terms are q of x, and this is the actual function value. This is the actual value, and this is actual, and this is approximation. The difference between these two will be the error, right? So f of x minus this q of x is nothing but this term. In that way, this is called error, right? So this is the error. F of x minus q of x, which will be the last term.
But sir, here the error will be a range because x3 is belongs to a comma x.
Correct.
Yes, sir.
Yeah, that is why we will not give the exact error, right? So what we do is we bound the errors, right?
Yes,
So
sir.
so we will say this absolute difference will be lesser than x minus a whole cube into. So you see this term will have a maximum value, right? So we can bound it using that. So what we do is we bound it. We will say x3 in the interval a comma x, and where should I write this? So x minus a whole cube into max of. Okay, so this will always be lesser than or equals to this particular term. Hence, I can say the error will always be upper bounded by this value. So the maximum possible error is this. So this is what we have to compute usually in our problems. So when they say maximum possible error, this is what they mean. Okay, and all other errors will be lesser than the maximum possible errors. So possible errors are of in some range, and everything is bounded by the maximum possible error. Okay, I hope this statement is clear, right?
Yes, sir.
Okay, great. So now coming to the problems. So usually the problems would be of two types, right? So one is they will ask us to find the approximate value, which is we have to find this, right? If it is linear approximation, we have to find this. If it is quadratic approximation, we have to find this, right? Asking for an approximate value. The other one would be asking for the maximum possible error. For that, what we have to do is we have to find this and this, right? And they say maximum possible error. That means we have to find this. We have to bound the error, right? So for that, we need to know how this f triple prime of x3 behaves, because if you know that, we know how to find the maximum or minimum values, right? So that we have learned in the very first lecture of this particular week, right? So yeah, that's it. So these are the two types of problems that you can encounter with respect to Taylor's theorem or Taylor's approximations. Okay, one is asking for the first three terms, which is called the approximate value, right? And the last term is the error term, which they will ask for the maximum possible error. Okay, so let's do some problems. Any doubt in this theory? I think I haven't discussed everything in detail. Okay, so go back to the lectures and watch the lectures. So in lectures, professor has used curves. He has also proven. If you want proofs, go back and see the proofs. So if I sit on solving or deriving proofs, then the whole session will go on that. Okay, so let's not do that. Let's try to do some problems. And let's do activity questions only. I think activity questions are quite sufficient. Okay. Or if you have any questions in activity, you can ask me. Which GA, Govind, are you referring to? Okay, week 6, I think deadline is not over yet, no?
Yes, sir, it's not over yet. Today it's
Yeah.
the
Yeah,
deadline.
yeah. So you have time till today night. Maybe on Sunday's session we can discuss the question. Okay. So I was told that you guys have some doubts in Taylor's theorem. Can you, those who have doubts, can you all ask?
So can you please like discuss the practice assignments first?
Practice assignment questions related to Taylor's theorem, is it?
Uh, Also, I think like the whole thing within the week 6.
Sorry, whole?
Like in like the not only on the Taylor theorem, on the other theorems too.
Acha, okay. I just have to go question by question in practice assignment. Is that what you are saying?
Yes, sir, if you can.
Okay. So let's see. Uh, Sayed,
Sir, activity 8, question number 3.
activity 8, question number 3. Okay, linear approximation. State Taylor's theorem for linear approximation around x is equals to 1. Okay, let's do that. So as I discussed, linear approximation, we have the function given to us as square root 1 plus x minus x square on the interval 0 comma 1. Okay. So in this interval, it is given to be function behaving like this, and after 1, we don't know how the function behaves, and we want to approximate, we want to come up with a linear approximation around x is equals to 1. So for that, we know that the linear approximation is f of a plus f prime of a into x minus a plus some f double prime of some x2 divided by 2 factorial x minus a whole square. Right, so here a, first identify what is a. A is 1 because we are finding in the question they ask like we want linear approximation around x is equals to 1. So a is 1, right, and then we need to find f prime of a, f prime of a and f of a, right. We need these two things. So f of a is very easy, which is f of 1. If all I have to do is substitute 1, which I will get 1. For f prime of a, I need f prime of x, right. So the derivative of, we have f of x to be square root 1 plus x minus x square, which implies if I take the derivative, this will be 1 by 2 root 1 plus x minus x square into 1 minus 2x. Am I correct? I just wrote.
Yes, sir, it's correct.
Okay. Good. So now if I want f prime of 1, again it will be 1 by 2 into 1 into 1 minus 1, 1 minus 2, which is minus half. Right, so we have f of 1 and we have f prime of 1. The next thing I need is f double prime of x2 or some u. So in the options it is given as u, whatever we will find. So we have f prime of x 1 minus 2x by 2 root 1 plus x minus x square. Now we have two functions, right? So this you can write it as half, you can keep it like that. 1 minus 2x into 1 plus x minus x square whole power minus half. Right, so now we'll treat this as some u of x and this as some v of x. If I want f double dash, or if I want the derivative of the product, all I have to do is I take the derivative of the first function, multiply it with the second function, plus take the first function and product it with the derivative of the second. Right, so this will now become half whole into u. 1 minus 2x is u of x. So u prime of x will simply be minus 2 into v of x is 1 plus x minus x square whole power minus half, plus u of x is 1 minus 2x and the derivative of v of x. V of x is 1 plus x minus x square whole power minus half. Its derivative will be minus half 1 plus x minus x square whole power minus 3 by 2 into 1 minus
1
2x.
minus 2x.
Right? So if I simplify this, 1 by 2 minus 2, 1 plus x minus x square whole power minus half, plus you will have minus 1 minus 2x whole square by 2 into 1 plus x minus x square whole power minus 3 by 2. Okay, so I think we should further simplify this. Let me do it real quick. Okay, so if you have any doubt, just ask me. So this will be minus 2 into 1 plus x minus x square minus 4 minus 1 minus 4x plus 4x square whole divided by 2 into 1 plus x minus x square whole power 3 by 2. Okay, so I'll have to simplify this. Minus 4 minus 4x plus 4x square minus 1 plus 4x minus 4x square whole divided by 2 into 1 plus x minus x square whole power 3 by 2. Okay, so now you can see minus 4x plus 4x plus 4x square minus 4x square will get cancelled out. All we'll have is minus 5 by 4 1 plus x minus x square whole power 3 by 2. So this is f double prime of x. Right, so yeah, so I think we have all the ingredients. All we have to do is just substitute them. So if I just substitute them, I'll have f of a to be 1, f of x will be 1 plus minus half into x minus 1. So let's write that linear approximation first, or I will just take this. Okay, so we have f double prime of x to be this, right? So let's take this and yeah, paste it here. Okay, so this we need. this we need, and this we need. That's it. So using these three, I can now write f of x. That f of x will be f of a, which is 1, plus f prime of a is minus half into x minus 1, plus I need some for x2, some x2, right? So this x2 will be in the interval of 1 comma x, right? Some 1 comma x. Okay, so that is minus 5 by 4 into 1 plus x2 minus x2 square whole power 3 by 2 into x minus 1 whole square for some x2, right? Around 1, you can think of like 1 minus epsilon to 1 plus epsilon or some interval. Okay, so for some value x2, this is how our f of x looks. And I think if you just compare it with the options, you see that option B, right? Right. So
Excuse me, sir.
yeah,
So for these types of question, first you have to find out all the things like the f dash of x and f double dash of x. And
correct,
after like that, we have to substitute the values in the given formula.
correct.
And sir, I wanted to ask one more thing.
Hmm.
Uh, sir, the a value, like how to consider the a value? It's like from the interval, the y value will always be the a
Uh,
value.
no, a value, no. Mostly it will be given in the question itself. So even if you see activity 6.8, the same question in question 3. The second statement, state Taylor's theorem for linear approximation around x is equals to 1. So you look at that around x is equals to 1, right? So that will tell you the value of A.
Okay, sir. So
Okay.
the value which is like uh, with the round word, that's is the value of a.
Correct. Correct. That will be the value of A in most of the questions.
Answer to
In
find like f of a or like f of 1, have to just substitute that value.
correct.
Okay, sir.
Okay.
Yes, sir.
Yeah. Amit, I think this is clear, no?
Yes, sir.
Oh, sorry, Sayed. Okay, I think option B is correct for this. And this is how we do. Okay, let's do some more problems on Taylor's theorem. So let's see within same 6.8 itself. Let's do question 5. Okay, it's on second order approximation. So the question is, so this is AQ 6.8, question 5. So the question is about which of the following represents the second order Taylor's approximation of the function f of x is equals to x minus 1 whole power 1 by 3 around x is equals to 8. So let me write that. Let's say find second order Taylor's approximation of f of x is equals to x minus 1 whole power 1 by 3. And it is also given that around x is equals to 8. Okay, so this around x is equals to 8 will give us the value of e. Right, so this is value of a. What we have to find is the second order approximation term, not the actual Taylor series. We don't need the Taylor series. They are asking for the approximation. Right, so all we need is without the error term. Right, so they asked for second order Taylor's approximation. So that means they need this q of x, which is f of a plus f prime of a into x minus a plus f double prime of a right. So this is the approximation, and if you add the error term, that will be exactly equals to the function. Okay, so here from this we can see that a is 8. Right, so once a is 8, we know f of a, which is f of 8, which is 8 minus 1 whole power 1 by 3, which is 7 power 1 by 3. Right, so f of a is easy. For f prime of a and f double prime of a, we need f prime of x and f double prime of x. So f prime of x, we can see that this will be 1 by 3 into x minus 1 into x minus 1 whole power minus 2 by 3. For f double prime of x, this will be 1 by 3 into minus 2 by 3 into x minus 1 power minus 5. Right? That's all right. So from here, I can find f prime of a, which is f prime of 8, which is 1 by 3 into 7 power 2 by 3. From here, okay, you can see f double prime of a is f double prime of 8, which is minus 2 by 9 into, you will have sorry, this is 7 power minus 2 by 3, again minus 2 by 9 into 7 power 5 by 3. I am writing this in the denominator. Okay, so here also we can write it in that way. This is 1 by 3 into 7 power 2 by 3. This is minus 2 by 9 into 7 power 5 by 3. I can also rewrite this as minus 2 into 9 into, I can pull out 1 7 into 7 power 2 by 3. Right, I can also do that. So 7 power 5 by 3, I can write it as 7 into 7 power 2 by 3, which will simply be minus 2 by 63 into 7 power 2 by 3. Right? Okay. All right. So this is correct, no? Any mistake did we do? This is f of a. 1 by 3 into 7 power 2 by 3 is f prime of a. And for f double prime of a, we are getting minus 2 by 63 into 7 power 2 by 3. Okay, so let's substitute, and then we'll get the quadratic approximation to be 7 power 1 by 3 plus 1 by 3 into 7 power 2 by 3 into x minus a, which is x minus 8, plus minus 2 by 63 into 7 power 2 by 3. Right, so that is f double prime of a divided by 2 factorial into x minus 8 whole cube. So this will, if you simplify this will be into x minus a minus 1 by 63 into 7 power 2 by 3 into x minus z whole cube. So this will be the second order Taylor's approximation. But if you see the options, I think they have given plus in all three terms. Okay, might be an error from their side, or I hope we did correct, right? So all are, is there any plus minus? Did I put it wrongly? No, this is correct, right? Did at least any one of you try?
Yes, sir, I'm getting the same thing.
Minus, right? The last term will have minus, no?
Yes, sir. Yes, sir.
Okay. Okay, so in options, I don't see any minus in the quadratic term. Maybe there is a high chance that the answer given was incorrect. Okay.
Excuse me, sir.
Yes.
So I wanted to ask something like, sir, how to find the formula? Like, I'm not getting that. Like, I'm able to substitute the values, find the answer, but I'm not able to find the formula for like the approximation. Like for the 2 degree, if we have to find for 2 degrees, so like, what should be the approximation and what should be the formula with the error value also? Like, how to find that? Not able to get that.
How? Oh, sorry. Just a second. Now this is square.
Yes, sir. It should be square.
Yeah. Yeah. So that is square. So it's, see, how to find the formula.
Like, you took like the q of x is equal to f of x. Like, how to get that? Or like,
Okay. So as we were discussing, no, there is an approximation term plus there is an error term which will give the exact function value, right? Here in this particular example, they asked us the approximation value. So you
yes,
see, in quadratic approximation, or what Taylor's theorem says is there is an approximation term plus there is an error term. So if I am asking you to give me the approximation term, you should only pick this, right? It depends on the question. So if I ask you for the approximation, you have to pick this. If I ask you error, you have to pick this, right? Or if I ask you the Taylor's expansion, then you have to give both.
uh, okay. So the only the last term is
This
the
is the
term.
error term.
Okay.
Okay. So if I have asked you cubic approximation, then you will have four terms, and then comes the fifth term will be the error, right?
Okay.
So you see, you look at this quadratic. So that means you need to have x square, right? So quadratic has x square, right?
And
Till,
and this would be same for the linear also. Like for
yes,
if
linear also. So
so.
linear approximation should have x.
Okay.
So till x you will take, and after that whatever comes will be the error.
The error form. Okay.
Okay. So in that way you have to choose.
Okay, sir.
All right. So these two problems that we have done is on approximations. Right. So here
Yes.
we tried to compute the approximation. Above also we tried to get the Taylor series expansion. So let's solve a problem which involves error. So which they ask for the error. Okay. So that's where things get slightly trickier also. Okay. So the same activity, question 4. And after this, let's go to practice assignment. Okay, so question 4 is actually related to question 3, which we have solved, right? Which is this, given f of x like this, 1 plus x minus x square on the interval 0 to 1, Open. Right. So in question 4, what they said is they wanted the Taylor series linear approximation around x is equals to 1, which we have found. And what they want is find the maximum possible error at x is equals to half. Okay. All right. So for that, we need to understand the error term first. Right. So let's write the Taylor's theorem for linear approximation once more. So since it is linear approximation, you will take the first two terms, which will be the linear approximation plus the error term. Then comes the error term f double prime x2 divided by 2 factorial x minus a whole square. And this is our error term. Right. And this is the linear approximation. So for this problem, we have already computed this f of x. So f of a plus f prime of a into x minus a plus f double prime of x2 by 2 factorial into x minus a. So let's take that. So what we got is f of x is equals to, if you just scroll up a bit, so this is this problem. Right. So we have solved this and this is what we got. So let's take this. All right. So we have already solved for that and we got this. Right. So this is, again, we have to decide all these three terms. Among these three terms, the first two terms are linear approximation. And this is the error term. Right. So now this problem focuses on this error term, this term. So they are asking us to find the maximum possible error at x is equals to half. Right. So the error is, if I say this is L of x, linear approximation to be some L of x, some other function. So the error will be the difference between these two. Right. So this is, this we know, which is this minus 5 by 4 into 1 plus x2 minus x2 square whole power 3 by 2 into x minus 1 whole square. Right. So this is the error term. At x is equals to half. Right. So that is where we have to find the maximum possible. At x is equals to half, this error will be f of half minus L of half. Right. On the right hand side, we'll have minus 5 by 4, 1 plus x2 minus x2 square whole power 3 by 2 into, in place of x, we'll just substitute half. So this is the error, but we don't know what x2 is. So that is why what we do is, we'll say this is lesser than or equals to this half minus 1. We'll keep it as it is. We will find the maximum value of this minus 5 by 4. Right. So maximum value of, I will choose x2 such that this 5 by 4, if I put absolute value, minus 5 by 4 1 plus x2 minus x2 whole square whole power 3 by 2 gives me the maximum value. Okay, and this x2, I will just pick between 0 to. Okay, so I have to come up with some x2 such that this value becomes maximum. And that will be the maximum possible error. Right? So now the problem or our goal is to find the maximum value of this function. Right? So the maximum value. So for which x2, this function will become maximum. So if you look at the function, it is minus 5 by 4 into 1 plus x2 minus x square whole power 3 by 2, right? So it's very difficult to get the maximum value using some analytical methods that we know. So for getting the maximum value, what we have to take? So take this as some g of x, some function g of x, and we find g prime of x and equate it to 0. And then we'll get some values, x values. And then we will find g double prime of x to decide the maximum. Right? So these things we can do.
Excuse me,
But
sir.
yeah.
Like if the double prime of g double prime of x is greater than 0, then it's a maximum value, or
Then it will be minimum, no?
greater than 0 would be minimum.
Correct. Z double prime of x greater than 0 will give you the minimum value at x,
Okay.
at that particular x. Yeah. If it
And
is less than, then it gives maximum.
okay.
Okay. So we have to do all these things. But since this is an activity question and we have also given hint saying that use Desmos. So we can clearly use Desmos and see at which point this attains maximum. Right. So maybe if you guys have joined with laptop or if you have laptop, just open Desmos and look at how 5 by 4 into, or you can pull out that 5 minus 5 by 4 also out, right? It is independent of x2. So look at 1 by 1 plus x2 minus x2 square whole power 3 by 2 looks. Right? So I will also show you here. I'll just plot it for you guys. Okay. So let me present it here. So you can see this. Right. So if you see, we are interested in the interval 0 to 1. So in the interval 0 to 1, you can see at 0, it is giving us value 1. And the function is decreasing in the interval 0 to 0 0.5. Till 0 0.5, it is decreasing. And from 0 0.5, it is increasing to 1. Right. At 1, again, it attains value 1. So within this interval, the maximum value is attained at x is equals to 1 or x is equals to 0. In both cases, the maximum value turns out to be 1. Right. So we need maximum value. Right. So in both at x is equals to 0 and x is equals to 1, it attains value 1. That is what we need. So that means the function will not go above 1. You can also see that from the graph, right? So the function value for any x within the interval 0 to 1 the value is lesser than or equals to 1. And it will be equals to 1 at x is equals to 1 or x is equals to 0. Okay, I hope.
So this is a
This is
maximum then.
at x is equals to 1 or x is equals to 0 will be the maximum value, no? Within that interval.
Okay, sir.
Right? In both the cases, the function value is 1.
Oh,
Right? So we need the function value, not at which it attains. Right? So let me present this screen back. So we need maximum value of the function. We don't need at what value it is giving us the maximum. Actually, we need x2, but this whole thing is about maximum value of this function. Right? So this function attains maximum value 1 at x is equals to 1. So therefore, this will be lesser than or equals to half minus 1 whole square into, there is 5 by 4, into the maximum value of 1 by 1 plus x2 minus x2 square whole power 3 by 2 in the interval 0 to 1 is 1. Right? So therefore, the maximum possible error is half minus 1 is half minus half whole square is 1 by 4 into 5 by 4 into 1. This will be 5 by 16. This will come out to be approximately 5 by 16 is 0.3125, right? Something. Yeah, 0.3125. All right, so this will be equals to 0.3125. Okay, so the maximum possible error is 0.3125. So this is how we should compute. Okay, so here the function is little bit complicated. So that is why we use Desmos. But some known functions, right, which doesn't need Desmos. All it needs is just the intuition. Right, so something like these functions: 1 by x square, 1 by x power 3 by 2, x square, x cube. Okay. Can we plot these functions or understand these functions without Desmos? What do you think? What do you think 1 by x behave?
As it tends to infinity, it will become 0.
0. Right. So this is very standard curve, which we all know. It will be like this, right? So once you know your f double prime of x, or this error term has this kind of expression 1 by x. So we know that the leftmost point of the interval will attain the maximum value, right? So if you are interested in these two intervals, in this interval, I want to find the maximum value of 1 by x. So you can clearly see that the leftmost point, okay? So the leftmost point will attain the maximum value. How does this 1 by x square behave? Any thoughts?
It will also behave similar, but
Correct.
yes, sir.
Something
And we'll
like
get
as x
the
increases,
maximum value at the leftmost
leftmost
interval.
point.
Yes,
Correct.
sir.
So again, in any interval you choose, the leftmost point will have the maximum value. Whereas coming to these functions like x square, x cube,
The rightmost will get the maximum value.
very good. So that's it. So x is simply like this, x square we know will be like this, right? And x cube will be like this. So now we can see you choose any interval, the rightmost points Interval contains 0, we can't find maximum possible error for this function. Okay. Yeah. Because at 0 it will blow up, right?
Yes, sir.
Yes.
So, excuse me, sir. Like,
Yeah.
sir, like, if for 1 by x, like, for the above function, the above
Hmm.
problem, we took like 1 there because
Hmm.
it was between 0 and 1 interval. For,
Hmm.
for like, if it would be 1 by x, then it would be directly 0.
0, but you should not take the case like 0, 1. If it is 1 comma 2, then it attains maximum value at 1. So you don't need to do this kind of f prime. So g prime equated to 0 and then c double prime. You don't need all these things. Just intuition is sufficient. That is what I wanted to convey here. Okay.
No, sir, like, but I just wanted to ask, like, for the maximum possible error, like, we founded a value, no? Like,
Correct.
so, like, if the function was like, the above function was 1 by x only, so then
Hmm.
what would be the maximum possible value?
So that will shoot up to infinity, no? At 0, it is going to infinity, right? 1 by x.
Yes.
So the maximum possible error will go to infinite.
Oh,
Okay. So
and
if it is something like 1 comma 2 and you have 1 by x,
yes, sir.
then you don't have to do these steps.
Actually, here, sir, x2 belongs to 1 by 2 to 1.
1 by 2
Because,
to 1. Correct,
yes,
correct.
sir. Because
Yeah,
we are finding the maximum possible error around x is equals to 1 by 2.
correct.
Yes.
I should have written, yeah, 1 by 2. So my point is, if you have something like this, max of some x2 belongs to interval a comma b, and you are trying to find the maximum value of 1 by x2.
So this will tend to infinity.
No, this will not tend to infinity. The maximum value will be attained
At a.
and at a, that will be 1 by a. So the maximum value will be 1 by a, and you don't have to compute 1 by x2's derivative and equate it to 0. You don't have to do the standard approach to find the maximum value. All you have to do is the leftmost point of the interval will turn out to be the point at which the function attains the maximum value. Okay, so that is what I wanted to say.
Okay, sir, I got it now.
Okay. And for functions like x square, and x cube, it will be the other way around. Look at the interval. X square will grow, x cube will grow, x also will grow. So look at the interval. And if you have something like max of x2 belongs to some interval a comma b, x square, this will be equals to b square. Okay. So the maximum value will attain at point B, the rightmost point. Okay, just careful about these kind of expression. If you encounter these expressions, then our life is very easy. So either leftmost point or the rightmost point will be the maximum value. Okay, so this is one thing.
Okay, sir. Now I got it.
Yeah, great. So yeah, as I said, some tips maybe for exam or here. So this is tip number 1. Look out for expressions like 1 by x or x square or something. And the next tip is, since we are asking for, mostly we'll ask for the maximum possible error. Okay, so maximum possible error. Right, so this maximum possible error, if you see, if we are asking for the linear approximation, remember that your form will have something like this. Okay, so the next term will be the quadratic. Right, so if it is linear, you have to, in your error term, it will have the double derivative. So one higher derivative other than linear. Okay, so a quadratic will have okay, and one note here is do not forget. Usually we'll forget this the denominators. Okay, so even the max errors will also have this factorials in the denominator. Okay, so just watch out for it. And yeah, so mostly practice problems related to linear approximations and its errors and its error and quadratic approx and its errors. Okay, so for linear approximation, so I will write all these four things for you guys, which will make your life very easy. So the linear approximation is L of x, which is f of a plus f prime of a into x minus a. Okay, you will have only linear term and the constant term. That's it, two terms. And for this, error is f double prime of some point x2 by 2 factorial into x minus a. Okay. And usually we will say error, as I said, is the max possible error. When it is max possible error, it is some maximum value of this. And always have absolute. Okay. So don't give negative values. So error is error. Even if it is negative side or the positive side, we'll take absolute value. Okay. So this is for linear approximation and its max error. For quadratic, which is denoted as q of x, this will have three terms: constant term, the linear term, and the quadratic term. And again, the quadratic term, do not forget this 2 factorial. So this will have this. Okay. And it's for this maximum possible error would be, as I said, it's a quadratic approximation. Quadratic is 2. So in your max error, you will have third derivative. So the next derivative, some x3. So max possible error again, maximum value of x3 such that this f triple prime x3 divided by 3 factorial into x minus a whole cube. Okay, so practice more problems which involves these three expressions, these four expressions. Okay, so again, in revision sessions also we will emphasize more on this, but it's like an heads up for you guys, so you can start solving problems from now on, and again, which involves these four expressions. Okay, so I think with that, Taylor's series and linear approximations and quadratic approximations using Taylor's theorem. Okay, so today is the deadline. I think you should submit your week 6 assignments as soon as possible. And even in practice assignment also, there are a lot of problems. We'll also release practice assignment solutions for week 7. So you can take a look at it. Sorry, week 6. Did we release it? No, right? Okay. We will release the practice assignment solution. Take a look at it and submit your week 6. And from tomorrow or day after tomorrow, start week 7. So week 7, we will deal more on power series and all. and you'll encounter different tests to say whether a series converges or diverges. So that is all new topic, which will come in week 7. Okay, so let's finish week 6 as soon as possible, and we'll start week 7. Okay, so any doubts or anything that you guys want to discuss, we can, or else I am done mostly. Any doubts?
No, sir.
No, sir.
No? Great.
No, sir.
So as I said again, I wanted to emphasize on this Taylor's theorem, and there is a lot of theory that was discussed in the lectures also. Even if you don't understand the proofs, do not worry. Do not hold back. Okay, so just move on with the results, and at least for examination points of view, these 4 expressions that you are seeing on the screen are important. Okay, and you just appreciate the results, and you should know how to use the results. That's it. Okay, so that's the primary goal. If you understand the proofs, if you understand everything good, you're on track. But even if you don't understand, don't stuck on the proofs or don't stop. Okay, so that's my point. All right, guys, then that's all for today. We will meet on Sunday with the new concept.
Okay, sir.
Okay.
All right.
All right, guys.
Thank
See
you, sir.
Yeah. Have a
Thank
great
you,
day.
sir.
Thank you, sir.